So here we are on part 2 of our note guide. So this is to be used to check your answer, or if you're still stuck, you can follow along for a couple examples. But I do want you to try a couple of these on your own or with those sitting around you. So suppose you deposit $1,000 in a fund that pays 7.2% interest compounded annually. And they want you to find the balance after 5 years. So first of all, if we start with it and we know it's going to grow, this is going to be an exponential growth problem. Okay, so let's look at each of our values. So since it's a growth, we know our equations can be y is equal to a times, parentheses 1, plus, because it's a growth, r raised to the t. So now that we have that, we want to find our a, r, and t values. So a is our initial amount. So we start with $1,000 in the bank. So that's our a. 7.2% is what we compound annually. Okay, and compound means just putting into the bank. Okay, 7.2 is our rate, but we want it as a decimal. So we move our decimal place 2 spots. We get 0.072. Okay, and then lastly, 5 years. So that's our t. Let's plug in the values that we know. So a is 1,000 times 1 plus 0.072 raised to the 5th for the 5 years. When you plug that into your calculator, you get 1,415.71. Okay, this is money, so it's going to be in dollars. So it's $1,415.71 in your bank account after 5 years. Okay, make sure that you're typing in exactly as it's written. And the way that you get the exponent is caret 5. Okay, or caret whatever your number is. So at this point, you can pause and try the second one on your own, or continue watching as we go through number 2. So suppose the population of a certain endangered species has decreased 2.4% each year. Suppose there were 600 of these animals in a given area in 2003. What is the approximate number of these animals in that area today? Okay, so if it's decreasing, that means it's a decay. We're losing animals. Okay, so let's look at each part. So our initial amount is 600. That's what we started with. Okay, our rate is 2.4, but that as a decimal would be 0.024. And then we started in 2003, and it wants to know today. So to find our time, we're currently in the year 2017. We're going to subtract that starting year of 2003. 2017 minus 2003 is 14. So our exponential decay formula is y is equal to a times 1 minus r to the t. Now let's plug in what we know. So y is equal to 600 times 1 minus 0.024 to the 14. When you plug that in exactly as it's written, you get 427.02. Okay, now we can't have 0.02 of an animal, so we're going to approximate this, and there's approximately 427 animals left in this year. Okay. So that's number 2. If you want to continue watching, please move on to number 3 with me. So example number 3. In 1990, the population of Washington, D.C. was about 604,000 people. Since then, the population has decreased about 1.8% per year. Predict the population of Washington, D.C., and instead of 2016, because we could easily look that up, let's look at 2019. So since it's decreasing, we are going to be looking at a decay. Okay. So using our decay formula of y is equal to a times 1 minus r to the t. Okay. So our A value is 604,000. Our rate, if we change that to a decimal, is 0.018. In 2019, so it started in 1990. So to find our time, we're going to subtract 1990 from 2019, and we get 29. So plugging in what we know, we get 604,000 times 1 minus 0.018 raised to the 29th power. When you type that in exactly as it's shown in your calculator, you get 356,673. We were talking about population, so we are talking about people. And that's how many people are left as the population of Washington, D.C., or how many we think will be living in D.C. in 2019. Okay? And then lastly, number 4. So the starting salary for a new employee is $25,000. The salary increases by 8% per year. What is the salary after 5 years and after 15 years? So if we're increasing, we have a growth. So our equation is y is equal to a times 1 plus r to the t. Okay. 25,000 is a. 8% is our rate, which as a decimal is 0.08. And then we're going to have two equations, one for 5 years and one for 15 years. Okay? So after 5 years, we have y is equal to 25,000 times 1 plus 0.08 to the 5th. When we plug that into our calculator exactly as it's shown, we get $36,733.20. So again, this is salary, so we do need to have our dollar sign with it. And then we want to find after 15 years. So we get y is equal to, again, 25,000. We're still starting with that. Times 1 plus our rate of 8%, now raised to the 15th. When we plug that into our calculator exactly as it is, we get $79,304.23. So that's how much this new employee would be making after 15 years at the company. So that's all we have for solving exponential growth and decay equations. If you have any questions, please ask me and continue to work through all of these. And that's all we have. Have a great day.